In example 3, we're going to look at how to solve trig equations by factoring. The instructions say to find all the solutions of the equation on the interval 0 to 2 pi. This means that our answers should only be between 0 and 2 pi. That means we're not going to have to add the plus 2 pi n or the plus pi n at the end of it because we're restricting how many answers we can get. So for part A, we're going to go ahead and solve cosine of x times sine of x equals 3 cosine of x. Before we even start this though, I want to show you a quick example of a simpler equation. If we were to have x is equal to 2x, one thing you would not do is divide by x, because then you would get 1 is equal to 2. If you did this, that would not make any sense. What you have to do is subtract x from both sides, and you get 0 is equal to x. Using the same kind of idea, we're going to look at our trig equations, and then we're going to realize that we cannot divide by cosine. Even if we did, they would cancel, but then we'd be missing out on one of our solutions. So what we have to do is subtract 3 cosine from both sides. Now be careful. This does not become negative 2 cosine. It's cosine of x times sine of x minus 3 cosine of x, and it equals 0. Now what we have to do is look to see what these two have in common. So we notice that both of these have a cosine x, so we factor out cosine, and you get sine of x minus 3 is equal to 0. And now that these are being multiplied, we're going to set each of them equal to 0 using the zero product property. And now that they're both set equal to 0, we can solve this pretty quick. Cosine of x equals 0 when x is equal to pi over 2 and 3 pi over 2. And then for this one, you add 3 to both sides, and you get sine of x is equal to 3. Now remember, the largest output that we can have for sine and cosine is 1. So this one is no solution. So our final answer is simply just pi over 2 and 3 pi over 2. Okay, moving on to part B. This problem is structured just a little differently. So as you can see, we have something to the fourth and something squared. What I'm going to do is a calculus trick, but I'm going to show you guys how to do it. You can rewrite cosine to the fourth as cosine squared plus cosine squared minus 2 is equal to 0. Now the trick I'm going to do is I'm going to let the letter u equal cosine squared. So wherever I see a cosine squared, I'm going to go ahead and put the letter u. So I get u squared plus u minus 2 is equal to 0. It doesn't matter if you use x, y, w, j, a, or u, or any other letter. I'm just using it as a placeholder and to make my factoring easier. So then my goal now is to factor this. So to get u squared, it's u and u. To get a 2, it's 2 and 1. My 2 is positive, my 1's negative. And you're going to now do u plus 2 equals 0, and u minus 1 equals 0. Solve it for u, and you get u equals negative 2, and u is equal to 1. So now we need to put back our substitution. So we let u equal cosine squared. So right there, I'm going to put a cosine squared is equal to negative 2, and cosine squared is equal to 1. At this point, I need to take the square root of both sides. So I get cosine of x is equal to plus or minus the square root of negative 2. This one's going to have no solution because you cannot have a real answer with a negative under a radical. And then for the other equation, I take the square root of both sides, and I get cosine of x is equal to plus or minus 1. So this is where this branches off into two problems. Cosine of x is equal to 1. and cosine of x is equal to negative 1. So now what I need to do is go ahead and solve those. Cosine of x equals to 1 at x equals 0 and 2 pi. And x equals negative 1 at pi. One thing I do want to point out is that we actually cannot have 2 pi as an answer because it's not in the interval 0 to 2 pi. It has to be between 0 and 2 pi. Notice how this one has a bracket and this one has a parentheses. That means that the bracket's included and the parentheses is not. So our final answer is going to be x is equal to 0 and pi. All right, so let's move on to the next one, part C. This one is very similar, just a little different. I'm going to start off by subtracting the square root of 2 from both sides. And I get 4 cosine squared of x plus 2 cosine of x minus 2 square root of 2 cosine minus radical 2 is equal to 0. So now what I'm going to do is if you factor by with 4 terms, you factor by grouping. So I'm going to factor these, and then I'm going to factor these. So let's start with the ones that are highlighted in green. They have a 2 cosine in common. And if I factor out a 2 cosine, I'm left with 2 cosine plus 1, and then plus, and then if I factor the things in yellow, they have a radical 2 in common. So I'm going to factor out a negative radical 2, and I'm left with 2 cosine plus 1. And that whole thing equals 0. So now if we look at this, they both have a 2 cosine x plus 1 in common. So I'm going to go ahead and factor that out. And I get 2 cosine of x plus 1 times 2 cosine of x minus radical 2. It might be helpful to go practice a refresher on factor by grouping if you're a little confused about this. So now using the zero product property, we're going to set them both equal to 0, and then we're going to solve each one. So for the first one, we're going to subtract 1 from both sides, and you get 2 cosine of x is equal to negative 1. And then we divide both sides by 2, and we get cosine of x is equal to negative 1/2. So cosine of x equals negative 1/2 when x is 2 pi over 3 and 4 pi over 3. Now we do the second one. So we add radical 2 to both sides. And we get 2 cosine of x is equal to radical 2. Divide both sides by 2. And you get cosine of x is equal to radical 2 over 2. And x is equal to radical 2 over 2 at pi over 4 and at 7 pi over 4. And you go ahead and box that, and those are all your answers.